client application, and then in between you have so many APIs. Your OS will be actually communicating to your client application will be communicating to your APIs only with your operating system. Then operating system is kind of abstraction layer, is kind of hardware abstraction layer, which will talk to your hardwares. Like it will talk to your RAM, it will talk to your flash, media processors, embedded processors, and all those things. And then below that, if you want to connect to the network, you have radio interfaces, gateways, and network interfaces. So that is how your mobile computing architecture works. Okay, so from client to from hardware, you will have so many APIs. So APIs can be like, if you want GUI APIs, if you want to design some graphical user interface, you will be having GUI APIs for that. If you want to make some telephonic mobile phone applications, then you will have phone APIs. So APIs is nothing, it's an application programming interface that will provide interface from application to operating system. Okay, so every operating system will have its own specified defined APIs. You cannot take an application which is designed for some operating system and can run on another operating system, because that needs to be specific, right? Because it depends on the API which is being provided by the operating system. So you are developing some applications which will be running in that particular operating system. Okay, so that is how your mobile computing architecture layers is, and that is how your application actually works on your operating systems, on your mobile operating systems. So this is a big picture about how your hardware looks like on your mobile. If you see on your mobile, you will be having your displays. Okay, so here you have displays, and display will be with your touch controllers. If you have some touch controller will take the data from the user, and then it will give it to the display. So this is how it is connected. So you will be having all your radios, your Wi-Fi controllers connected to the radio Wi-Fi radio interface, Bluetooth controller. If something you want to connect to the board, you will have expansion handle. You can connect it to that, and you can also expand your GPIO's pins. And you can connect some interfaces. You can connect some sensors to the GPIO's pins. Okay, so JTAG will be there. JTAG will be using for your debugging purposes. You can directly debug your SoC. You can directly debug your hardware. Okay, this is runtime debugging on your hardware. So JTAG will be debugging in that case. So based on serial and RS-232 cable, you can connect your serial communication. Some serial communication you can do. USB hub is there. Ethernet 5. So this is 5 for Ethernet. So basically we will have two processors in it. One for application processor that will be processing your applications, and one for baseband processors. Baseband processors are used for your radio communications. So if you want to transfer some Wi-Fi and these kind of Bluetooth, these will use some radio communications. Okay, so these will be handled by RF transistor chip, and that will be talking to your baseband processor. Baseband processor will do all your algorithms all your like analog to digital conversions, how you are communicating with how your data transfer from digital to analog. So all these things, it will check all your things. So baseband processor is used for that. It will have its own RAM, it will have its own flash memory. Okay, this is a big picture of your mobile, how your mobile is constructed with all these chips connected to each other. So basically we have smartphone OS in market. We have like Symbian, Windows Phone, BlackBerry OS. Symbian is from Nokia. We already saw that Symbian is from Nokia, and Windows is from Microsoft. Similarly, BlackBerry OS, Windows Mobile, Apple iOS. We have one iOS operating system from Apple, and then the most popular one, Android operating system. This is which is provided by Google. Okay, this is the most popular operating system which we have here. So what is Android? So I'm going with a little fast because we have less time. Already 20 minutes were already wasted in the connection. So if you have any queries, please let me know through chat. So I will be going a little fast today. So yeah, if you have any queries, please let me know through chat. So your Android You all are able to hear me, right? You all are you're able to hear me perfectly there? Yeah. Hello. Yeah. So what is Android? So Android is basically a Linux-based platform. It's a mobile platform. So it will be having your operating system. It will also have your middlewares. It will also have your applications, and it will also have software development kits. Uh, so software development kits to develop the applications. So it will constitute all these things. Your from operating system to your applications, it will contain each and every layer. So this is all Android architecture. We will be discussing Android architecture in later slides. So what is Android? Basically, Android is a software stack for mobile devices that includes an operating system to your applications. It will contain your operating system, middleware, your SDKs, and your key applications. Then it is basically purchased by the Google. Google is the it purchased the initial developers. I'll talk you about who are the initial developers of this Android. So Google have acquired this Android in 2005. Okay. So Android mobile operating system is based on Linux kernel, and Google and other members of Open Handset Alliance. Open Handset Alliance is a collaboration. It's a group. You can say it's a consortium of some companies which together and build some good operating system that is now being known as like Android operating system. The Android so this is the most important property of this Android operating system is it's an open source software. So we call it as Android open source project. So this is an Android open source project that is being maintained and developed by Android community, and that community will have so many companies together. They collaborated each together, and the major part of this is being acquired by the Google. So Google now have total complete authority on that Android. Okay, so Android was listed as the best-selling smartphone platform worldwide in quarter four 2010. It was the best-selling smartphone platform Android. Okay, so what is Open Handset Alliance? Open Handset Alliance is one consortium. It's one collaboration of several companies. So in the next slides, I have like distributed these companies. So the companies from semiconductor companies like you have ARM, you have Intel, Broadcom, Athos, NVIDIA. So Athos, ARM, all these will ARM will provide the ARM core, like I told you about ARM processor, right? The ARM IP is being provided by the ARM company. Athos will provide some like Wi-Fi chips. Broadcom will also provide some Ethernet chips or some multimedia chips. So the all the chips which I showed in the previous slides being designed by these semiconductor companies. Okay, semiconductor companies this like, and similarly we have some software companies like eBay, Google, then we have these companies. So they collaborated each other. So commercial companies will also have handset manufacturers like we have HTC mobiles, LG mobiles, Sony mobiles, Samsung, Acer, Asus, and Toshiba, Motorola. All these are OEMs, original equipment management, manufacturing. OEMs is original equipment manufacturing. So those will manufacture your handsets. Okay, and then we have some mobile operators also. So mobile operators like Sprint and Vodafone. So so these are the group of one Open Handset Alliance, and those who are contributed towards your Android operating system. It's a standard now. It becomes a standard for all the mobiles. Okay. Android is basically a faster growing mobile operating system, and around 3 lakh Android activations per day will be happening. Okay. Android overtook iOS. iOS is a popular operating system which is being used in the US, and it's being manufactured by Apple. Also, Android overtook iOS as a dominant OS in US also. So in US also, Android is very being popular over there also because it's an open source, and many companies came together to bring to bring out some good stuff. Okay. Now first there is one first phone that is launched which is HTC G1 in 2008, which is using Android. So currently an OS is the best choice for Motorola, Samsung, Sony, Ericsson. These are all OEM vendors, OEM mobile vendors actually. So you will also get software updates every few months. You'll have new versions of Android. So it being started from 2005 to till now, we have lots of versions of Android operating systems. We will be looking into the versions of mobile operating system on this Android operating in the later slides. So how it goes, the history, I'm talking about history here. So in 2005, Google buys Android from the Android Incorporations. Then in 2007, uh, they formed one open handset alliance that has been, the partners of this open handset alliance will be Google, Motorola, Samsung, Vodafone, and T-Mobile's operators, mobile operators. And then we have the first version of Android 1.0 released in 2008. After the 2008, we in 2009, we have Android 1.1, 1.5. So 1.5 is the name given to this 1.5 is Cupcake that will be released. Then they are releasing one by one and they're giving some names depending upon these donors, Aclair, for you might have heard, you are using smartphones, you might have heard about all these things. So Android 1.6 is Donut, Android 2.0 is Aclair's, 2.2 is Froyo, 2.3 is Dinglebat, Honeycomb. Like this, they are launching year by year. Okay, the new facility, new features they are adding to the Android operating system and they are releasing year by year. So the current work for you transitions for user interface, good user interface, you can develop good applications over there. So I already told you that when you add some more APIs, operating system will not be compatible to the backward operating system because the application which will be using the APIs for that particular OS needs to support all the APIs. If some API breaks, your mobile will crash, your operating system will crash. So in that case, uh, for each and operating system, there will be an API level. API is your application programming interface. So which API it is compatible with. So if you are using some Android previous versions of Android like 4.1 and you want to execute one application which is being developed for the API version 19, for example, if you're making an application for API level 19, you cannot run that on the operating system which is having an API level 60 because there is no API compatibility. Okay, so that programming interface compatibility should be there. So with each and every OS, with each and every versions of Android operating system, we have a defined API level. Like API level 1 for Android 1.1. Android 1.1 will use API level 2 like this. From Cupcake to KitKat, we have 3 to 19 levels, API levels. Okay, so in 2013 we got this. Now the recent versions of Android, which is like Android Lollipop. Android Lollipop comes in 2015. And then Android in the starting of 2015 we got Android Lollipop, and then last of 2015 we got Marshmallow, and recently in August 22 maybe we got Nougat, Android Nougat, that is Android 7.0. So Lollipop is Android 5.0, Marshmallow 6.0, Android Nougat is 7.0. So now here is what I was talking about, the API levels and the initial release dates. So Nougat is released on 22nd of August and which is having API level as 24 and version number. So these are all your version numbers, API levels. So yeah, so you can actually check your in your smartphone your settings and build number. If you will see, you will get which Android operating system you are using with which version number and which level you are using. If you want to create some application, you want to install that application in your mobile, you have to create that application for the particular API. Okay, you need to select that particular API level in your SDK, Android SDK. Then only you will be able to run that application on that particular OS. Otherwise, that application is not going to run. Okay, so this is how your Android symbols looks like. So alpha, first version 2008 comes as alpha, then beta, then cupcake, donut, eclairs, froyo. After froyo, we have gingerbread, honeycomb, ice cream, jelly bean, Kit Kat, like this. So Android at a glance, like this is a software stack for mobile device. will contain OS, middleware, key applications, and the source code is open, as I already told you. And open means there are the Android community which can actually contribute to the features of this operating system. And application framework will reuse of discuss about WL virtual machine in depth later slides. And then we have users. We have some 2D graphics libraries, OpenGL libraries, 3D graphics libraries, SQLite as a data storage, is database actually. Media support, it will support the media supports like MPEG4. These are all codecs, H.263, MP3, ACK, JPG, PNG. And it will also support some video interfaces, Bluetooth, Wi-Fi, camera, GPS, accelerometers, and software development kits also, and GSMs and all those things. So now we will discuss about architecture of Android. Do you guys have any questions till now? We will be entering into architecture of Android. Let me know if you have any questions up to these slides. If you guys have any questions, please let me know up to these slides. Okay, so yeah, so now we will be entering into the architecture of Android. Okay, so this is how Android architecture looks like. So as I already told you, Android is based on Linux operating system. It's based on Linux kernel. So at the lower level, your main operating system will be your Linux kernel. That kernel will be actually talking to your hardware. So the kernel will be having some drivers which will read and write your hardwares, which will talk to your hardware. So drivers like you have audio, binders, IPC, Bluetooth communication, camera, display, keypad, all this will be taken care by the kernel. Then above that we have hardware abstraction layer. So what we are doing here, the hardware abstraction layer, I already told you, like hardware abstraction layer is always being like directly you cannot talk to your hardwares. Okay, even though you have the Linux kernel, we are providing some kind of abstraction for the Linux kernel also, that the application should not directly talk to the Linux kernel also. They will not talk to Linux kernel directly. They will go to the hardware abstraction layer. Suppose if I have some Wi-Fi application running, then Wi-Fi application will talk to the some hardware abstraction subsystem within the Wi-Fi in the hall layer only. Okay, it will be taking the services. It will be taking the services from the Wi-Fi module within the hall layer. Then hall layer will be actually talking kernel layer. Okay, so why we are actually doing this kind of abstractions? Because we want maximum utilization of the hardware. Even though we have some features within the kernel, we are again abstracting it to make it more utilized, because we are going to run so many applications and we are going to give Wi-Fi functionality, Bluetooth functionality to many applications. If I have 5 applications running, I want to services to all the 5 applications like that. So we need some kind of hardware abstraction layer so that all the services efficiently we can provide to the application. Then over that whole layer we have native libraries, and then we have Android runtime layer. Above that we have Android framework, and above that we'll have applications. We will be deep in the deep. We will be discussing later in these slides. So this is how it looks like. So these are all the layers of your operating system. So at the lowest layer, you will be having Linux kernel, which will be talking to your hardware. Okay, in there we will be having display drivers, camera drivers, Bluetooth drivers, then your power management, your audio drivers, your Wi-Fi drivers, your keypad drivers, your USB drivers, if you have any USB devices connected. So like this, each and every device is like being handled by your driver, specific driver, associated driver. Camera is being handled by the camera driver. Bluetooth is being handled by the Bluetooth driver, like this. Wi-Fi driver, USB driver, like this. Okay. So above that we have hardware abstraction layers. So for each component again we have some like graphics, audio, camera, Bluetooth, GPS, radio. So we have some top of hardware abstraction layer. We have libraries. Okay. So the APIs which I was talking about, the APIs will always build better libraries. Okay, The APIs, that application interface is being provided by libraries. Libraries will have the implementation of those APIs. Suppose I want to read something. I want to store something in some database. So for that, we are using SQLite as a database library. SQLite as a database library, I want to store some data into database, then I will be using the APIs related to SQLite database. SQLite database. I will be at SQLite library. I will store that data into that particular some locations by using those APIs provided by the SQLite database library. Okay. Suppose we have surface manager. We want to create some surface. We want to create some views on user space applications. We will be using surface manager libraries. Then we want to hear some audio, video, play some video, audios. Then we will be taking APIs. We will be taking APIs from the libraries called media framework. If you want to hear something, audio manager. If you want to display something, if you want to display 2D graphics, you want to display 3D graphics, you'll be using OpenGL and ES libraries. Okay. Like this. If you want to create, use some fonts, different kind of fonts. So FreeType is one library which provides fonts. So libc is the standard library. WebKit, if you want to use browsers programming, if you want to do, then WebKit will be using. If you want to use some APIs for secure communication, then you'll be using SSL library for that. Like this. So you will have so many libraries which will be included in the software stack, Android software stack. Above that, we will have application framework. Application framework is kind of services. So this will provide all the services. Like you have activity manager, window manager. So here we will have all the managers. Like I want to manage some activities which is running in my application. I can have so many activities which is running in my one application. So all those activities will be like you have. Suppose you have opened something and you are like swapping on your application. Okay, you are swapping in your application. So that swapping, when you swap something, your activity will change. That previous activity will go in sleep, and your new activity is coming in resume. Like those activities like swapping, sleeping, going awake, and all those conditions will be managed by your activity manager. Okay, then window manager will be there. Window manager, like all the window you are seeing in your mobile phones, that will be managed by a window manager. Then you will have content providers. What the content you want, you can have some services from content providers. View system will be there. Notification manager. When you scroll down something from on your smartphones, you have some notifications, right? Notifications and shortcuts. So that notification stuff will be provided by your notification manager. If some notification is there from an application, that needs to be managed by your notification manager. Okay. Location manager, some GPS location. I want to run some application which is going to use some GPS kind of stuff. So some location kind of stuff. I need some location. So for that, we need location managers. Like resource manager, we need some resources. Okay, CPU resource, memory resource. So you will use resource manager for that. Telephony manager. Telephony manager, we want to use some GPS, some receiver transmission kind of stuff. We want to talk to someone. So those APIs, those services will be provided by your telephony manager. And package manager, we want to install some package. We want to install in Android. We want to uninstall or install. That will be handled by your package managers. So each and every services that is there will be managed by some kind of managers, and that manager is called application framework. Okay, so application framework, and top of this we will be having applications. Application like your home, your dialers, your IM, your browsers, your camera application, your calculators, your contacts, your email, calendar, like this. Okay, applications at the top layer we will be having then application framework, your all managers. Above that, below that, we will be having libraries, APIs provided by those libraries to the application framework and then to the application. And the most important thing we have one system is Android runtime. Okay, Android runtime we will be discussing for Android runtime in later slides. So Android runtime will be having core libraries and one stuff Dalvik virtual machine. So I will be discussing Dalvik virtual machine, what it does and how we actually execute and how we actually how we get the APKs. Okay, so that is being designed. That's the work of your Dalvik machine, your Dalvik virtual machine. So this is something about like what kind of languages we are using at each of these layers. So at the lowest layer, the Linux kernel is all about C. We are using C in there. Then if you come above, we have your libraries. the library should be written in, some part of the library should be written in C and some part will be written in C++. Okay, why we have C and C++ here is like the lower part which will be communicating to the Linux kernel will be written in C only. Okay, you can that is more preferable when you have C to C interface, that is more preferable. And for your application framework, we have C++. C++ will be talking to your Java app frames, application framework, and all your applications within Android mobile operating system are being written in Java only. So we are using only Java to create your applications. So Java framework, we will be having bytecodes and Java. So this is called design goals. Like we have open source here, and then we are using high flexibility here, high data accessibility, and XML. We are using XML files and Java language. Okay. So for OS and drivers, we are using C library, C++, and framework for Java. Application also for Java only. So in Android architecture, I already discussed these things. So this is what your stack architecture is all about. This whole architecture is your open source architecture. Okay. So this software architecture will be consisting of your Linux kernel, libraries, Android runtime, then which will be having core libraries and dynamic virtual machine. Then we have application framework, application layer, and application protocols. Okay. So at the lowest layer we have Linux kernel. We can have different versions of Linux kernel, like from 2.6 to 3.6. This is the mainline Linux kernel frame. We can take the mainline Linux kernel and we can add some features like binders. They are added for Android. They can create Android Linux kernel. Okay, by adding some extra features within the mainline kernel, within the main Linux kernel. And the advantage of Linux kernel is like it's portable. We already know that Linux kernel is portable to many hardwares, to many of the architectures. Like it can port this your PowerPC architecture, your MIPS architectures, your Spark architectures. And the best thing is like it can port to the ARM. And what we are using is on mobiles is we are using ARM Cortex series. Okay. So this is why it is portable, it is scalable, and it is secure. There is multi-process environment. We can run multi-processes. We can run multi-threading. We can do multi-processing, multitasking, multi-programming. All those we can do. And we have good power management facility which we can provide for the Linux kernel. So Linux kernel will be utilizing less power. So that is what we need. The ARM processor itself is also for low power consumption. Okay, because in mobiles we are using battery. We don't want battery to be drainage. So okay, so we will be using some mechanism so that we can reduce the power. So power is the most concern for the companies nowadays. The research is going on for the power because we are having so many applications running and the performance is enhancing day by day, but the most important thing for those applications to run is power. Like if you use your Wi-Fi, if you use your Bluetooth, your IoTs, all those are using some radio interface, some radio frequencies. So radio frequencies will need some current, right? And then the current will be drained from your battery. Battery will drain out fast. So the research is going on how we can actually reduce the power consumption so that battery can be used for longer. Okay. So the Linux kernel, basically this is what we have. We have the proven driver model, and then we have memory management system, we have process management, security model, networking, a lot of core OS infrastructures here, and core system services we will be providing with the Linux kernel. And this is something about internal architecture of a Linux kernel. So Linux kernel architecture is basically like it will be having 5 systems. One is your memory manager, that is called memory subsystem. One is your file system. One is your IPC inter-process communication. One is your network, and one is your this process scheduler that is in between. So process scheduler is being it will talk to all your things. So if process want memory also, right? Process want some data from your file system. File system will read from your hard disk. So if that process is there in the hard disk, it will that process needs to talk to the file system also. And then it wants from process to process communication. The process to process communication is being done within the inter-process communication subsystem. And it also wants to access your networks through sockets. Want to connect to the network, so it will contact your network layer also. So this is how your manager, your file system, your IPC, your network all these are connected to your process scheduler. That is the main part. So, and how your application to your process scheduler, that will be talking to through one system call interface. So your from your API will be calling some system calls. The system call interface will talk to your processor, and the processor will talk to your all these subsystems. So we will have some architecture independent schedulers and architecture specific schedulers. So we will be having some scheduling policies also to schedule the process. Which process I want to run back, and which process I want to make in sleep, and which one process I want to make in awake. All these decisions will be taken care by the scheduling which policy I'm using. So let's basically use like round robin policies. It uses your round robin. It uses other policies also. Okay, it uses FIFO policies also. Round robin and FIFO. Basically, the general policies to use by the Linux kernel. And yeah, the scheduler will be your complete fair scheduler. The complete fair scheduler is like it will be giving a fair time to each and every process. So it is not giving all the time to one application only. So it is giving some slots depending upon the nice value, depending upon all the scenarios, like how much time left for the process to run to complete its task. It will decide on those scenarios. The short scheduling algorithms will decide how much time I need to give to this that application. Application can go and sleep voluntary also. If they are waiting for some IO operations, if they are waiting for some input output operations, they will just release the process. They will release the CPU actually. They will release the CPU, and CPU will, and again the scheduler will actually call another task. It will give that task to CPU, and CPU will run that task. Okay. So this is something the internals of your Linux kernel architecture. So in Android architecture, we already discussed about native libraries. What all native libraries we have here. So the libraries like standard libraries, secure socket layer, surface managers, OpenGL and OpenES, and we have SGL, media frameworks. We have free types for fonts. We have WebKit for browser engines. We have SQLites for databases. Okay, so these are all your libraries, which will provide some aid to your application framework, and then by using that application framework, we can actually design our applications for the Android operating system. And then this is the important part, that is in the Android architecture we have Dalvik, and Dalvik previously we used to have a Java virtual machine. See, why we're using Java virtual machines here is like when you have Java application, when you compile with Java C compiler, okay, Java compiler will be there. It will be converting the Java C compiler into the bytecodes. And can be running there. So it's kind of platform independent. Without knowing about the platform, we can design the application in Java. We can create the Java bytecodes. We can, if the virtual machine is there in another platform, we can take that bytecodes and we can actually run that bytecodes on other. That is why it's like good to have working with Java. Okay, so what we are doing here is we are using Dalvik virtual machine. Dalvik virtual machine, previously we used to have Oracle Java virtual machine. So they optimize that Oracle Java machine for the memory constraint, and now this Java virtual machine is more faster than original Oracle Java virtual machine. Okay, what Java virtual machine, this Dalvik virtual machine will do exactly, we will be discussing in the later slides. Okay, as of now, it is just for like it will convert the bytecodes to the your executable code. What executable code is there? So this is like Android runtime, which meets the needs for running in an embedded environment, where is limited battery we are using, memory is limited. Okay, you know, on the mobile device we have the limited battery, we have limited CPU, we have limited memory. Okay, so we need something like Dalvik virtual machine, which will actually create some applications which will be using limited memories, which will be using limited battery, to be using limited CPU. That is all been defined at the time of we are designing the application only. So it will take the resources. So resource file will be there actually, which will take the resources like CPU time, how much CPU time it will take, how much battery time it will take, battery power consumption will take, how much memory it will take. So all this information we are actually resource files. Okay, and then we have core libraries like Java programming language we are using. It will contain all the classes. It will contain your utilities, your IO utilities. Okay. And then the one thing is Java. So we have optimization. The Dynamic virtual machine is being optimized for memory requirements. Okay? It's being optimized for low memory requirements, and DVM will convert your will run your bytecodes. Already discussed about this. It will be running your bytecodes. Those are called text files, and then it will be converted at the build time. When we are building the application, those bytecodes will be converted to some executables. Okay. So it will be more efficient and run very well on small processors. Structures are designed to be shared across processors, due to which multiple instances of DVM running on device at the same time, one in several processors. So this is your application libraries, application framework, all the managers I was discussing about. So these are managers. Now we come to Dalvik. So your Dalvik virtual machine, all application written in Java are converted to executable. So all the Dalvik executable .ex. If you want to execute something, all your Java should be converted to DEX bytecodes. Every Android app runs its own process and its own instance of DVM also. So every application will have its own process, and each and every process will have its own instance of DVM. So we can create so many instances of DVM as we are running our applications. Okay, so we can replicate DVMs, virtual machines, to run those applications. So okay, so VM uses Linux kernel to handle low-level functionalities. So this Dalvik virtual machine actually talks to your kernel to handle low-level functionalities, like it uses security, it uses threading, it uses process, it uses memory management. So all these things, it will be taken care by Dalvik virtual machine. How much memory I need to give, what type of how many threads I need to create, how many processes I need to create for an application. That together with the Linux kernel, that the Dalvik virtual machine layer, the core layer, will decide that stuff for each and every application. Okay. So this is how your core libraries works. So the core APIs for Java will be provided by core libraries. That's a part of your Android runtime. Okay, Android runtime will have core libraries, and it will have Dalvik virtual machine. So Dalvik virtual machine will convert your .java application. When you write your application, you will be the extension for that application is .java. So .java application will be converted by your Java C compiler, and it will convert into .class. So dot class will be converted by text tool to .text, and then .text files will be taken by APK. The one tool is there again, which will convert that into application packages. .apk is the application packages, and then ADB is the actually Android debugger. Android debugger that will actually run your APK. So this is how it works. So dot class files, it will take your text tool will take all class files, dot class files, and it will mix that dot class file, data files, and the resource files. Resource files is what we are talking about. The resource file will have the resources like CPU resources, memory resources, all those resources, what all databases, what all things it needs, it will be captured into the resource files. Resource files will be together with the application dot class files and dot data files and dot data text files will be given to the app tool. Okay, AAPT tool, and then AAPT tool will create final package. It is the final package, it is the final executable which will be running, and actually you can distribute this as a package on your you use Google Play, right? When you install some application from Google Play will have the packages in the form of APK only. You can actually install those .apk in your Android by taking from the Google Play, and you can also download from internet. All those APKs will be generated by the finally it will be generated in the APK form. Okay, and it will be converted by your AAPT tool is there. Okay, so this is how Dalvik virtual machine works. Any question regarding Dalvik virtual? Just let me know any questions regarding Dalvik virtual machine. Yeah. Okay. So there are some images like Android images we will be forming. So at the for the hardware to initialize, we first of all we want to initialize the hardware, right? It's an application package. APK is nothing. It's an application package only. At the DAX full form, I'm not sure of DAX full form. We can get back in the next sessions. What is the DAX full form is basically. You can also search on Google DAX full form. You can search. If you have some concept-wise problems, you can ask me. So basically, I'll be discussing like U-boot. Difference between .ec file and .text file. Okay, .exe file and okay. So basically, what .exe file is the executable which will be using your Windows operating system. Okay, so when you create a .exe, the file format. So like we have API, application programming interface. We have some kind of ABI, application binary interface. So these are all binary formats. Okay, so Android will be using some another binary format. Windows will be using some another binary format. Linux will be using some another binary format. Okay, so that is called application binary format, application binary interface. Okay, so here in Android we use dot. It's a binary format. .exe. It's a binary format. So .exe for Windows, .exe for Android. Okay. Any other questions? Okay. Yeah. So this is what we have when we if you see in your mobile devices memory, flash memory, we actually put all the images. Like we want U-boot image. U-boot is the bootloader, which will actually initialize all your hardware at the initial stages. When you powered on your mobile device, the first thing which will come into bootloader. Bootloader will be reading that bootloader will be kept in the ROM. ROM will actually read from the ROM. We are actually reading the bootloader. Bootloader, when it runs, it initializes all your hardware. It will initialize your memory controllers. It will initialize your CPU. It will initialize your hard disk. Everything it will initialize slowly. Okay. Whenever it needs what you want to initialize, it will initialize that first. So first of all, it will initialize the RAM memory. So that's how your bootloader works. Then we have Linux kernel. Bootloader will after initializing all your hardware, bootloader will actually load your Linux kernel from some memory locations, and then so that the Linux kernel will be in the boot.image. So these are images which we are actually putting into the flash memories. Okay, and then we have system.image. System.image will have all your application framework. It will also have your applications. It will have your libraries. It will have your runtime, Android runtime framework also. So these are the most important images, like image for bootloader, boot.image for Linux kernel, and system.image for your application framework and libraries and applications, some defined applications. So this is how your dynamic virtual machine works. So previously, previously we used Oracle Java virtual machine. Previously we used Oracle Java virtual machine that actually based on stack based byte coding, and nowadays we are using actually register based byte coding. Okay, so register based byte coding is faster actually. So accessing the register is faster actually, because in stack we need to push and pop the stuff to get the data. If we have the register, we can directly access the register directly from the memory location. Okay, so register based processing is faster than stack based processing, and also we can actually efficiently use the memory in case of register based byte codes. So nowadays we are using dynamic virtual machine. So that so Java source code will be converted by Java compiler to Java bytecodes. Java bytecodes will convert it into dynamic bytecodes by the text compiler, and then it will be running on your dynamic virtual machines. Okay. Each instance of your process will be running by each several instances. Like different instances will be there for dynamic virtual machine to run each and every instance of application process. So this is like your Android this is what all the applications are. You have all the applications here. So you can have third-party applications. You can have activities, application regarding 2D graphics and 3D graphics, and some you can create some widgets also. Okay, and this is all. This is your open source architecture. So open source means the users of Android and the developers of the Android and the industry makers, the OEM makers will actually they can actually talk to each other regarding some features. If user wants some applications, they can talk to the developer. Developer wants some hardware functionalities, they can talk to the industries, OEM vendors. They can actually create their hardware such that developers will feel okay, we can use this capability which is being provided by the hardware. Developer cannot do anything which if there is something which is not being provided in the hardware. Hardware manufacturers needs to provide the functionalities first. Then software developers will provide will take care of, okay, we can actually go ahead and implement this kind of functionality which will be provided by the hardware. And then if that thing is being done by the developer, user will take care and user will actually use that. Okay, users are us. So we are actually using the experience of the hardware of the softwares. So it's kind of open communication. Since it's an open source communication, we can the communities are actually communicating to each other, and then they're developing some good operating system like mobile operating system. Okay, so there are some application components here. So for application, we already told about activities. We need some activities, some screens, some user interfaces to be taken care by your activity manager. Then we have content providers. Then you have services. Services is being provided by your Android framework. Okay. Then you have broadcast receivers. Okay. If you want to some packets through your Bluetooth and from your Wi-Fi packets, you can use broadcast receivers in that case from your application interface. Yeah. And yeah. So application framework. This is all about. We have we go over time, so we will. Okay, so this is how your Android application development happens. So for Android application development, we'll be using Eclipse IDE. IDE is the integrated development environment. Integrated development environment is basically integration of your Android emulators. What are Android emulators? Android emulators are kind of like you are emulating your hardware on top of software. So you actually can see, you can run your application and see in the emulator. You will be having one like a virtual device, virtual Android device, which will be implemented in the software form. That's called emulator. So that hardware emulators is being plugged with the Eclipse IDE, and Android SDK software development is being also integrated, and then Android mobile device also integrated. So it's an integrated development. When we do application development, we should know all about emulators. We should know about SDKs, how we can download SDKs, how we can plug in emulators in the Eclipse IDE, and how we can download Eclipse IDE, and how we can actually design some application within the Android application, Android mobile operating system. So this is how your emulator looks like. I was talking about Android emulators. Android applications may be run on a real device, or it can be run on your Android emulators, which ships with the Android SDK. When you buy some Android SDK, when you download Android SDK, you will also get an Android emulator with you. Yeah. So when you want to make some applications and you want to execute that application, but you don't have the target, but you don't have the hardware, you can actually run on your emulators. How it looks like. So this is how your development will be faster. You can develop your fast application. You can make some changes in the application, just quickly run it on your emulator. Emulator will show you, okay, this is how it looks like. If you want to make some changes, again, you can make some changes on the emulators. Okay. So there is one debugger called ADB, the Android Debug Bridge. So Android Debug is a command line shell. It will give you the command line shell, and with the command line shell, you actually communicate to your Android OS. You can actually communicate to your kernel also through your ADB. So ADB is a kind of bash command line shell. So it uses internally SH shell. So this is how your development environment looks like. This is your how you can create your projects. So this is a window of your Eclipse IDE. So you can plug in some Java development tools and some Android development tool plugins also. Java development, you need Java here. JDK you need. JDK is Java development toolkit. So JDK 5 and 6 will provide all the stuff related to Java. Okay. Because you are developing application in Java, you need some Eclipse IDE also for that. Okay. So how Android development is, you have Java sources, you have generated classes. Okay, you will create some classes from your Java source, and then you have some Android libraries, which are already discussed Android libraries. Those are all put together. It will be taken care by the Java compiler. Java compiler will take all those things and it will form a .text file. .text file will be taken by your Delphi virtual machine. It will run on landed virtual machines, DVM. I already discussed about DVM. Okay. So this is how your application lifecycle management works here. So at this point of time, you will not be able to understand this whole application process, but I will try to create something here. So what happens is, like, when you start any activity, when you touch any application, so this on create, on start, on resume, on pause, on stop, on destroy, these are all features. These are all APIs actually. Within the They are defined in the classes. Okay, they are defined in the classes, and then import the class. We will import the package in some application. Okay. So actually, what happens is, like, when you press on create, so you are actually creating one activity for any process, for any application. Okay. If you want to navigate back to the activity, okay, you can navigate back to the activity also. You want to restart, you can restart by on restart. So activity comes into foreground. It can go into background. Okay. If you want to resume, you will do on resume. If you want to start, you will do on start. Okay. If you want to pause something, some activity you want to pause, you can do on pause. Okay. If you want to destroy something, you will do on destroy. So when you are destroying something, your on destroy function will run and it will destroy that application. Okay. So these are all some basic functions for each and every application. If you design a simple hello world application also, a hello world application will also go through all these activities. Want to create it? On create. This is a predefined function which is being provided by Java API. Java API. Okay. Java packages. Yeah. So this is how your application works. So each application runs in its own process, and each activity of an app is run in the it will be taking the batch process. Process are started, they can be started, they can be stopped, depending upon the need. They can be killed and they can be reclaimed to needed for the needing resources, and okay, they can be restored at any point of time. If any application and we want to restore the last state of the application, we can actually restore the last state of the application also by the user. So this is actually what happens. So these are some client apps and web apps. If you want to create some client applications and Java your server applications, so you can create client applications also, Java server applications also, your web applications. They can actually talk together. So client and server will be talking to each other through some socket, through some sockets, or through some APIs. Applications also on your mobile operating system. So the thing is, like, network connectivity. Network connectivity, it supports wireless communication like GSM. It supports for mobile. You can talk on mobiles through GSM technology. And 3 gig supports. It supports 802.11. It's a IEEE standard for Wi-Fi networks. Okay, and this is an example of how actually Wi-Fi works. Suppose I have some Wi-Fi chipset. Okay, Wi-Fi chipset will be there in the hardware at the lower layer. Above that, we will be having some Linux kernel. We will have Linux kernel. Linux kernel will have some drivers. It will have different kind of drivers. So it will have your Mac driver, your CFG drivers. It will be a little complex for you to understand as of now, but I'm giving you a general overview how actually application works. How actually from your application to your hardware, how it happens. So from your application, if you want to when you enable any Wi-Fi, so Wi-Fi enabling will be handled by your Wi-Fi manager framework. So Wi-Fi manager framework will be there in the application framework that will talk to your libraries. Those are called lib hardware libraries, and there will be one daemon called WF supplying. That daemon will be running every time. And when you give settings, Wi-Fi is on, WPS like and weapon, the daemon will be running all the time. Okay, that daemon will take care. It will see if any of if we have some connections. Okay, if we have some connections, we will connect it to the application, and then application will be able to get the Wi-Fi data from the radio interface. So it will be taking the data from the radio interface to your Linux kernel, through your libraries, then your framework, and then your applications. This is how your actually Wi-Fi works. So this is an example how these layers are actually involved in each and every services. You want to use Bluetooth, Bluetooth will have its own stack. Wi-Fi, it will have its own stack. Okay. So So advantages of Android. So advantage of Android is like it's open source, it's open platform, it's free. Okay. So with Google Chrome, you can open many windows at once, and there is the support. The support is good support. We have a lot of support from the community. So you can read this. Yeah. Thank you for listening, for your time. Let me know if you have any questions, because we crossed the time. If you have any questions, we can